Okay, so backtracking to 9.3, we're going back to rate, time, and distance problems. But this time there's going to be two things that we're taking rate, time, and distance of. And they're either going to be going in opposite directions or they're going to be going in the same direction. So, for example, if I was doing a problem where we were going into opposite directions, let's say spring break, I drove to LA, and who wants to drive the opposite direction? Ellen drove to Sacramento. That's the opposite directions, right? Yeah. And the question is going to say, if Miss Smith drove at 60 miles per hour to Los Angeles, and Ellen drove at 65 miles per hour to Sacramento, how long would it take them for them to be 100 miles apart? So how long would it take for them to travel 100 miles apart from each other? Okay, not 100 miles total. Not 100 miles total. 100 miles apart. Okay? The other type is called a catch-up problem. So, for example, Alyssa left school at 2:40 and Keely left school at 3 o'clock. And Alyssa's traveling at 12 miles per hour and Keely is traveling at 15 miles per hour. How long would it take Keely to catch up to Alyssa? That's what it means. Okay? Okay? So, what we're going to be doing first is opposite direction travel. So that's, I'm going to LA, Ellen is going to Sacramento. Okay, what we first need to do is we need to define, we're going to get, because there's two people, there's two rates, right? So we're going to need to define both rates in terms of one variable. We cannot solve a problem if there's more than one variable. So we have to put them in terms of the same one variable. Okay? Step 2, we're going to set up a table that shows distance, rates, and time. And the kind of cool thing about the table is that it's always exactly the same. You never have to figure out what goes where, because it's always a column is distance, second column is time, first column is rate, always. Okay? Step 3, you are going to write an equation. And this is a step that's different than the next one. You are going to write an equation. Because we're going opposite directions, we want the total distance away from each other. So you're going to write an equation showing the total, distance. Thank you for reading and not just taking my word for it. Okay, so you're going to write an equation showing the total distance, because if I'm traveling 60 miles per hour south, I'm traveling a different speed and a different distance than Ellen is traveling, because she's going a little bit faster than me, right? But I want to know how long it's going to take us to be 100 miles in between us. Okay, so Ellen will travel a little bit further of that 100 miles than I will. Okay, and then the last step, we're going to solve for the variable. Okay, so let's read the first example. 2 trains left the same station at the same time. Amtrak traveled south at 52 miles per hour. So I'm going to do Amtrak in blue. Amtrak traveled south at 52 miles per hour. Orient Express traveled north at 28 miles per hour. So, purple. So Orient Express is traveling in the opposite direction, but traveling much slower, right? How many hours will they be 320 miles apart? Okay, here's my table. My table is always going to look this way. This is going to be person, train, car, plane, number 1. Person, train, car, plane, number 2. But then you're always going to set it up rate, time, distance. Okay, so it's always going to be rate, time, distance. Got it? Okay. Question. What's our variable going to be? X, but what's the question asking us for? Hours, so that's time, right? Time. So let's let T equal time. Is time going to be the same for both trains? It will be. The time will be the same for both trains. Why? Because I want to know how much time it takes for both of them to be 320 miles apart. So the time is the same always, right? Because they left at the exact same time. Okay? So t is time. So we actually only have one variable this time. Okay, so for opposite direction problems, you're always going to just have one variable. Okay? So, what was Amtrak's rate? 52. What's their time? Doesn't say, so we're going to let it be t. Okay, I don't know the distance. I know that they are going to be 320 miles apart total, but I don't know how many of those 320 miles Amtrak travels. What is the distance rate time formula? D equals R times T. I know R and I know T, right? So what's the distance? Well, I know it is T, right? So my distance is rate times time. I don't know what the time is yet, so I don't know what the distance is yet. Does that make sense? Yeah. Okay. So Orient Express is going to be the exact same thing. What's his rate? 28 miles per hour. What's his time? We don't know, so it's also T.
Can't we just set it up the equation of 320?
28 T.
And so the distance is going to be 28 T. Hold on a second. Okay, so I want to know how many hours it will take for the trains to be 320 miles apart. So Amtrak's distance plus Orient Express distance needs to add up to 320. So that's just going to be 52T plus 28T equals 320. Combine like terms. What is that? 52 plus 28?
That's
80T equals 320.
Divide.
Divide by 80.
It's 4. It's 40. What's not
So
4?
T equals
T. Oh yeah, 40.
4 what?
T.
4 hours. It's just 4. Those zeros cancel.
Oh, you guys tricked me.
So after they've traveled for 4 hours, they will be a total of 320 miles apart. Make sense?
Yes, ma'am.
What happens if we are traveling in the same direction? So now I have two people going the same direction or catching up to each other. Yeah, so like Alyssa and Keely leaving school. They're going the same direction. Step 1, you are going to define both rates in terms of one variable, and this time, for example, the time is not going to be exactly the same. Okay, so we are going to have to define the second unknown in terms of the other variable. Okay, so you will be solving for something twice. Step 2, you are going to set up a table showing distance, rate, and time. So the table actually looks exactly like the other one. Step 3 is the one that's different. You are going to write an equation setting the distances equal to each other. Because let's think about it. If Alyssa leaves school and is walking towards Clovis East, and Keely leaves 15 minutes after her and is walking to catch up to Alyssa, once they catch up, they've traveled the same distance, right? So we set the distances equal to each other in this case. And so then step 4, we're going to solve for the variable. Okay, so let's do it. Example 2. Sam left home traveling at 45 miles per hour. 1 hour later, his friend Mark leaves from the same place and travels the same road, but at 60 miles per hour. How many hours will it take Mark to catch up to Sam? So I'm going to do Sam in orange. Sam left home going 45 miles per hour. An hour later, that's the important part to think about, guys. 1 hour later, Mark left going 60 miles per hour. Okay? So their times are actually going to be different, right? Their distances are the same, but their times are different. So let's set up our table. First, we need to figure out what we don't know. Mark, he was going at what rate? 40. Mark?
Oh,
Mark went at 60.
wait, no, they don't know. Wait, what?
Oh, I did these backwards. Hold on. This should be Sam.
Oh, so confused.
I'm sorry, guys. We have Sam
Does it matter?
and Mark. It really doesn't matter, but I already did the work, and I put Sam's information in Mark's spot.
That's what I did too.
Okay, so this is Sam, Mark. Okay. So Sam, what was Sam's rate? 45. Do we know how long it took him?
1 hour.
No, we don't know his time yet, right? So T, well, is going to equal Sam's time. Or, yeah, time Sam left. So T is the time it takes Sam. So what's Sam's distance?
45 times.
45T. Okay.
Yeah, I've already got that filled out.
Okay, what about Mark? What's Mark's rate?
60.
60. Now, let's read this part carefully again. 1 hour later, his friend Mark leaves. Mark leaves 1 hour later than Sam. So what's it going to be? T minus what? 1 time Mark left. So his time is T minus 1. Okay? Because we have to include the time. The clock starts when Sam leaves. Mark leaves an hour later, so he's already an hour behind, right? So we have to subtract 1 from Sam's time. So then what would the distance be?
60 times.
60 times T minus 1. Okay, so let's set up our equation. When Mark finally catches up with Sam, their distance is going to be the same, right? They would have traveled the same distance. So we're going to set the two distances equal to each other, because the distances are going to end up being the same. Okay, solving this is easy. What do I do first? Let's distribute. So this is 45T equals 60T minus 60. We need to move, let's subtract 60T from both sides. So that's going to give me negative 15T equals negative 60. Thank goodness it's going to come out positive, right?
Divide by 15.
Divide by negative 15.
What's 5?
So T is going to equal,
5 hours.
no,
Oh, dang it.
4
Why
hours.
would it be 4?
Because 60 divided by 15 is 4.
I'm thinking 12.
Fail.
I don't know
Yep.
why he's
That's a
thinking
net.
So how long? Oh, no, that's not our answer. Think about it. Let's think about it. Sorry. T is 4 hours. That's Sam's time.
Oh.
But it took Mark less time, right? It took Sam 4 hours to get that distance. How long did it take Mark?
3 hours.
So it's T minus 1. So 4 minus 1 is equal to 3 hours. So we didn't, just by solving for the variable, we did not necessarily answer the question.
Do we have to write it in Word?